Hello, everybody, and welcome back to stage 3 of the Diana Initiative. Hello, hi, hello. Today we have Megan Carney, but before we get into that, a quick announcement. Please do not forget to visit our expo hall. We have sponsors with contests and swag, community organizations you should really find out more about, and a Red Team Village with 5 Red Team talks going on. And there are raffles happening over there throughout the event. We'd love to come see you over there. So please don't forget about it. Go visit the expo hall. And yeah, I am very happy to announce Megan Carney's talk, How to Sink the Ducky and Other Tricks. Megan Carney is Megan Carney has been an analyst slash bad news giver in several different environments over the past 10 years or so. She spends most of her time searching for all of the places badness might hide. She can often be found staring into the abyss, and according to her, it is true that the abyss stares back. We will be having question and answer for this talk. Please throw your questions in the stage chat, and I will collect them and I will read them off at the end. With that, I will hand it over to Megan.
Hey, everyone. So as he said, my name is Megan Carney. Just to talk a little bit about where I come from, right now I am a detection engineer at Target. And what that means is I spend a lot of time looking for where to find bad on the network. And in particular, I spend a lot of time building detection for our macOS machines, which is why I'm here today to talk about unified logs. And Josh mentioned the question and answer period. I am not up here today to talk to myself. In fact, I really wish I could be in front of people instead of here virtually. So I really do want you to drop your questions into the chat so I can answer them and maybe point you to other resources for things I don't know about. All right, so all that having been said, let's get to unified logs. Oh, switch the window. There we go. So in the beginning for macOS, or should I say OS X, we had syslog. And syslog was pretty basic, but it had this really cool feature where it was basically the syslog that everyone knows and loves from Unix or Linux, which means if you wanted to redirect logs to a server, you could just create a syslog config. And then your logs would go to a centralized system, and it made log collection really easy. But Apple being Apple, everything must change. And so we ended up with Apple system logs, which were these .asl files that still exist, by the way. And there is still data in Apple system logs that doesn't go into unified logs. I'm assuming that someday that will change. But for the moment, there is still data in Apple system logs. And again, being Apple, this was replaced again by something called unified logs. I'm showing a picture of this blog post on the eclecticlight.co site, not because I'm going to go into a bunch of information about how exactly the logs flow through the unified log system, but I wanted you to have a resource to go to if that's something you're interested in. Today, we're going to focus on what you can find in the unified logs and how we can use them. The thing that frustrates me with unified logs is there are a lot of features that I feel like are missing. And the first most basic one is that when you're in an enterprise environment, the #1 thing you want to do with your logs is send them to a centralized server, because you can't trust compromised machines, right? And you also want to be able to look for trends among multiple machines. And not being able to send logs to a centralized server makes that a lot more difficult. One of the other really annoying features is these unified logs are not text files. It's a binary format that has to be read on another host that understands the binary format. So you can copy logs between macOS hosts, and you can read them on other macOS hosts, but you can't just copy them to any old computer and read them like you can text files. So those are two features I really feel like macOS logs are missing. And, you know, if Apple is listening and wants to grant me a few wishes, if we could get that, that would be awesome. In addition to that, there are some weird gotchas while searching that I feel like I should talk about, because one of the things I would really think is cool is if someone sees this presentation and says, that's all nice and good, Megan, but I can find out a bunch of cool things in unified logs and tell you things you don't even know. And I would love that. So I'm going to give you a few tips if you want to go hunting in the unified logs. The first is, I found when I started working with them, there were a lot of silent failures because they don't work like grepping a directory of log files. So if you are used to old school Unix and you grep a directory and you run into a log file that you don't have access to read, it will tell you. And then you'll know that maybe there's something you're missing. If you don't run log show as root and there's a record that you would have seen but you're not seeing, log show does not tell you. And the same thing happens with info and debug. So these dash info and dash debug flags, those are what you send to log show to say, I would like to see debug level logs and I would like to see information level logs. If you do not specify those flags and the record you're looking for exists in one of those systems, log show does not tell you that you're missing something. It just says that it found nothing. Which, again, this sounds kind of simple, but I just want to call out that if you're used to old school grepping logs, then this will be very counterintuitive and it might come back to bite you. There are things called predicates, which are basically filters for the log show command. And I found that they didn't work completely like I expected them to. And if I ever have the time, I'll document specific examples and send it along. But for now, I just wanted people to know, if you're not finding what you expect to find, dump everything over the time frame for the event you're looking for, and then dig in manually. And then you can test your predicate filters to see which ones actually find the log lines that you already know are there. But speaking of time, there is some time weirdness in the predicate logs. I heard a couple people talking about this at Objective by the Sea this year as well. And we have seen cases in our testing where the timestamps on the unified logs were delayed by like 45 minutes. Not something you could attribute to a time zone, just something that's possibly a buffer delay. Since I haven't really dug into the logging binaries on macOS, I can't tell you any more detail than that. But what I wanted to mention this, so if you are building alerting for an event that you really, really, really want to catch, and say you're telling log show to look back 6 hours and you're running this alert every 6 hours, that if there's a delay, you might not catch the event you expect to catch. So you want to build in overlapping timeframes for your alerts to make sure that you don't get bit by this. All right. And I have one last thing I want to talk about before we get into the technical stuff. This presentation was built based on work we did on Mojave. And I have noted on the slides whether they apply to Mojave or Catalina or both. But I need to be perfectly honest here. What I'm sharing today is a sampling, not even everything, that was figured out over multiple weeks with multiple people working in teams to run test scenarios. Like, I'm going to transfer this file via Bluetooth. What shows up? I'm going to transfer this file over AirDrop. What shows up? And I wasn't able to retest everything before I gave this presentation today. If the past is any guide, the differences between Mojave and Catalina will be enough that everything I've built for detection will break for Catalina, but the targets will be enough so that the targets will be similar enough that I don't have to restart all of my research. So most of these queries were built for Mojave. They will probably be useful for Catalina, at least as a place to start. And I hope to repeat this and get better log targets for Catalina for the ones I haven't tested yet. All right. So I think those are all the sort of housekeeping stuff I wanted to talk about. Let's talk about why I'm here today. So there's a running joke that Macs don't get viruses, and then we all laugh and roll our eyes and say, ha, because we know they do. They do get compromised. They are used in lots of enterprise environments. And to be perfectly honest, we don't build detection around them at the same level that we do for Windows machines. And this is risky for enterprises. If your Macs are tied into the same AD infrastructure that your Windows machines are, then a compromise from a Mac could easily spread to the rest of your infrastructure. So we as a community and within our organizations really need to start pushing to get Mac detection up to the level, or at least up to the level that we have on Windows. So the first thing I'm going to talk about today is where the title of this presentation came from. Malicious USB devices like Rubber Ducky and Bash Bunny, which pretend to be keyboards and then run malicious commands on the operating system. I wanted to figure out how we could find them. And it turns out there's a really simple way to do it. And that is by looking for the firmware names for those devices. This command I've actually verified both on Mojave and Catalina. And it looks for this keyword. I think you can see my mouse here. Keyboard service added, or keywords, I should say. And this really, it's really convenient because it includes these nice tags here. So this is what Rubber Ducky's firmware name is, @malAVR. And for Bash Bunny, we have RNDIS Ethernet gadget. And it turns out that if you want to sweep your environment for whether or not these things have been plugged into your Mac machines, you can just look for these in your unified logs. So this is the simplest way to detect things like Rubber Ducky and Bash Bunny. Of course, there are some problems with this approach, right? Firmware can be recompiled. And the device that's targeting you may not be well known. There are a lot of malicious USB devices floating around. Some of them you can order on Amazon. So we definitely can't rest on the idea that you can build a full and complete list of all the malicious firmware on the market. So what are some other approaches we can use? We can look for things that are multi-use devices. One of the interesting things I found in my research is that many malicious USB devices register themselves as both a mass storage device, something like a thumb drive, and a human interface device, which is something like a keyboard or a mouse. And when these keyboards are registered, you get a hex string, which tells you all of the uses that that device is claiming when it communicates with the operating system. So I know this sounds a little bit confusing. So to go into the details, here's a screenshot of what the logs looked like before Mojave. And I realized this is a really grainy picture, so I took out the text that's really important here. It says add USB receiver, and then we get this 311-312. So if you go to this site right here, which I discovered during my research, it tells you that the base class here is a human interface device, and there are some subclasses, but they're not really important. What we're looking at here is a USB Bluetooth keyboard. There's nothing suspicious about it. Oh, sorry about the notifications. And I wish I could give you better than screenshots, but to give you an idea of the research that we did for this hunt, we literally went around the office, you know, when we could still go into offices, and we said, give me all of your weird, crazy USB devices that you've collected over the years, malicious or not. We're going to plug them into this machine and see what happens. And so after about a week of plugging every imaginable USB device, including some ones where they were of very questionable origin, I was not ready to connect this machine to the network to pull logs off of it. So we have a bunch of screenshots for this particular test case. But anyway, that is a USB keyboard. If you want to see what Bash Bunny looked like before Mojave, this is what we have. Notice we have the class codes again, but in this case, we have a communications and control device. It also registers itself as a mass storage device. That's the 8. And we also have this A, a communications a CDC data device. So this is 3 different base classes with 1 device description, and that's a little weird. So that was before Mojave, which shows you how long I've been looking at unified logs. And then Mojave happened and everything changed again. But I figured that the hex strings were in there somewhere. So I haven't managed to find them for keyboard registration, unfortunately, but I have managed to find them for mass storage devices. So this trick still works on Mojave, and I think they're in there somewhere on Catalina, and we'll talk about that a little bit later. So what you see here is the USB registration for a Bash Bunny, and we see here a class code of 8, which is a human interface device, and a class code of 3, which is a mass storage device. So if you are looking through your unified logs and you find a device that does both of these things, regardless of what the firmware name is, regardless of what they've recompiled it to be, you can detect it. I did test this one on Catalina as well, and this is what I found. In this case, this is not a malicious device because I didn't have any at home to test with. But what we have here is just a plain old thumb drive that I had lying around. And you can see that it's only registered itself as a mass storage device, which is what we would expect. So how can you detect these devices? This is pseudocode that I've put at the bottom here. I don't have the script to release for you, but it's really pretty basic. What you want to do is run these commands that look for either SU query or USB. Pull out that device description. That's this part right here. And then you keep track of all the base classes associated with that device. And if it has both class 3 and class 8, it's highly suspicious. And then if you want to go for extra credit, you can look for conflicting keyboard definitions. And what I mean by that is here is Bash Bunny registering itself as a keyboard. It has a location ID, it has a vendor ID, it has a product ID. And if you put these together as a tuple, you can use it as sort of an identifier for the keyboard on that particular machine. And if you find out that you have a device that has more than one description for that tuple, you could get false positives. So that's just extra credit, but we've had good luck building detection and testing that. We have actually tested that detection for just looking for this 0x3 and 0x8 pattern. But even so, as exciting as that is, this still doesn't cover malicious USB devices entirely. And the reason is because you don't always need to register yourself as a mass storage device to successfully compromise a machine. So in that case, what can we do? If you are a small enough org, you can profile what's normal. So this command right here will show you all of the keyboards that have been added to all of your machines over the past 7 days. And if your organization is small enough, this might work. Now, as I say this, I understand that we're all living in the after times and that a lot of companies have sent their employees home and that you might have a bunch of people plugging in keyboards that they found in their basement somewhere or in their closet. So this approach might not work for you, but it is still something to consider if you have a more tightly controlled environment. But what if there's another thing we could do. So I want to give credit for this technique to a coworker of mine. His name is Jack Voorhees. And he thought, what if we could detect the behavior of the malicious USB device instead of just detecting the presence of the device? So there is something, I'm going to take a step back here and talk about what the knowledge database is. It's a SQLite file on macOS that records a bunch of things, but one of the important things it records is application activity on the Mac. So it can tell you when an application was opened. This in focus keyword here means that that application was on the top of the desktop, so it was in focus. And it can tell you times for all of these. So we can actually pick up the pattern of an exploit inside the knowledge database. And this is a really simple pattern for something that registers itself as a keyboard. So we have keyboard setup assistant, and then types things into a terminal. And you can see the timing here is about, I think, 3 to 4 seconds, which is faster than a human would normally switch between those windows. So it's one way to pick up that pattern inside the knowledge database. And of course, this is just one type of exploit for a malicious USB device, right? But if you profiled more of the exploits for Bash Bunny, Rubber Ducky-like devices, you could certainly build a bigger database of what malicious attack patterns would look like. So that's all I'm going to talk about for malicious USBs for unified logs, even though I'm sure there's more to know. The other very useful thing that I've found in unified logs is ways to find lateral movement. And you can think about lateral movement as being able to SSH in or somehow run commands on other machines. And you can also think about it as the ability to move files within the environment. So you can either exfil data or move your malicious code around. So first, let's talk about being able to use things like SSH for lateral movement. If you are familiar with Unix, you will know that there are two really common commands called W and last that show you current and past SSH sessions, but only those sessions with an associated TTY device appear for those commands. And I'm not going to get into what a TTY device is because it doesn't really matter for this presentation. The important thing to know is a trick that our red team shared with me, which is really cute. You can actually start an SSH session without creating this TTY device. And you do it by this SSH-T flag. And when you do that, it hides that SSH session from the W and last commands. Oh, I'm almost halfway through and I forgot to tell you. I will be posting these slides if you check out my Twitter handle and just follow me for a few days. I'll post a link to them so you don't need to write everything down or screen capture everything. Yeah, I should have told you that before I clicked through all those queries. Anyway, on to SSH sessions. You can find all the SSH sessions in the unified logs. And happily, I was able to verify this command on both Mojave and Catalina. In this case, we're using another predicate called process image path, which basically you can think of as daemon, because we're saying we want to look for things done by this process, the SSHD process. And we're looking for this keyword accepted. You can see failed logins too, if that's something that's interesting to you. I don't have that query in here, but just so you know, the data's there. And here is a comparison of the output from W, the output from last, and the output from our unified logs. So, oh, I'm glad I have my pointer here. So here's a SSH session at 10:34. This is Central Time. And you see this SSH session in the output of W as well. And you can see it in the unified logs here at 1734 because I had it output in UTC. But what you don't see in this last output is this SSH session right here at 1732. This is the one I created with that SSH-T flag, which means that it didn't create a TTY device and it was hidden. So this is just an example of the SSH output for unified logs, and it's a super useful way to be able to track lateral movement inside your org. But SSH isn't the only way you can move around in an org. Remote Apple events, for those of you who are familiar with Windows, kind of like RPC. It operates on port 3031, which becomes important later. And while I haven't heard of any big attacks using remote Apple events, they are ripe for abuse because I don't know of many orgs that are actually looking for this activity, which you can find using unified logs. So we can find incoming remote Apple events. That means, was someone trying to initiate a remote Apple event on one of your machines using this hello from AE server message. And unfortunately, these are just for Mojave. There are a lot of test cases for remote Apple events, and it's going to take me a good solid week of testing to replicate this. But anyway, if you want to find incoming and outgoing remote Apple events, you can look for this keyword right here. Remember how I said that's the port number that remote Apple events operate on? It ends up being a really good way to find remote Apple events in the unified logs. So here's a sampling of what we get. These particular logs don't have the port number in them, but you do see this hello from AE server message. And what I wanted to call out in this screenshot is there is some sort of session marker. I'm using the word session loosely here because I can't tell you exactly what makes a session begin and end, but you can sort of track one person logging in with remote Apple events using these TCP connection IDs, which we're going to see more later. And you can see this AE server again appearing here. So this is what it looks like when a remote Apple events connection is started. Here's more of the port 3031. So here we can see outgoing remote Apple events. This is my test machine, the .2.1, a high numbered random port because it's initiating the connection, to a source IP, which it doesn't give you the IP address of. This looks like some sort of bookmark, and with enough time, you could probably find where to look it up within the operating system. But for now, just know that this means a target, but unfortunately, the IP address isn't listed. And for incoming remote Apple events, what we have are, again, a inbound connection, no IP address for the inbound host, and then this destination port of 3031. There's some more information down here where it gives you an IP address, but unfortunately it isn't in these log lines, and it's really frustrating to try and troubleshoot this when you're doing research. But it does give you some information about session duration, about bytes in and out, and all of that can be useful for forensics. There is some sort of connection teardown, and that's that TCP connection ID I talked about earlier. The connection gets closed, or as it says here, canceled, but you can reconnect within a time frame later. I don't know exactly what that time frame is without generating a new hello from AE server message. And again, this is on Mojave. Perhaps things have tightened up a little bit in Catalina. I don't know, but I think the important thing to recognize is that remote Apple events have some sort of session reuse. So when you're looking in the logs, just be aware of that. And this is probably the best overall trick I found. You can pin the time frame for remote Apple events use on the target using these unified logs. This weird little string, APRL, I have no idea what it references, seems to only show up for remote Apple events activity in Mojave. And you can see that string and then a connection ID, and then look at the first line where that connection ID appears, and then the last line, and get an approximate measure of how long that connection was active on the machine. We can also find the application that was launched via remote Apple events. Just the first one, but that is still super cool. What you're looking at the bottom here are the remote Apple scripts that I used to generate the activity on the target. So my target here is this 2.148 machine. And in this case, I told Finder to display a dialog box. In this case, I told Finder to open the news app. What you see in the unified logs is that I said open Finder. That's it. It doesn't tell you about the dialog box. It doesn't tell you about the news app. Unfortunately, I really wish it had everything. But this is still super useful because if you have another source of data, like say process logs, you can look for the process logs that occurred around the time, say, Finder was opened on the box, and then you would be able to trace the rest of the activity. Notice again that we have these session IDs. These are 2 different testing sessions, 2 different times, and they have these connection IDs that you can sort of use to track the activity per session. And here's another example. In this case, my Apple script opened system events. And you see here it says system events : AE, whereas on the previous slide it said Finder : AE. So in this case, I opened Finder. In this case, I opened system events. All right. That is it for remote Apple events. And I want to make sure I leave time for questions at the end. So just to go over a quick summary, while we didn't solve all the mysteries I wanted to solve with remote Apple events, we can determine if a host was a source for remote Apple events, if it was a target for remote Apple events, and the approximate time frame for that activity. We can also find out what application was initially launched. And all of these are super useful for tracking lateral movement. But as I said earlier, we don't just want to track lateral movement in terms of commands. We want to be able to track it in terms of files being moved around on the network. So let's talk about Samba sharing. These logs were pretty verbose, so I didn't dig into what each and every one means. But you can tell if the Samba server has been active, and that's with this com.apple SMD keyword, SMBT. SMBD, sorry. This one, unfortunately, I haven't had time to test on Catalina, but again, notice this info flag here and this debug flag here. The other thing that you'll notice is there is a time frame that you can pass to the log show command, and I recommend using this because otherwise it can run a long time if you haven't limited where you're looking. This is kind of an aside, but you can also run log show in real time instead of looking at historical logs. And in that case, you can just have it open in a terminal window and watch what's scrolling by. So as I said, these logs are pretty verbose, so I'm just going to give you a sampling of what we found. During the course of our testing, we actually discovered a user on our network that was extensively using Samba within like a group of employees. And so we ended up with a really good test case. For context, what you're seeing here is not the messages appearing in order. What I did was I looked at the first 80 characters of each event message, and then I sorted them, and then I counted them. So you don't need to really understand the Unix commands, just understand that this is a sorted, counted list. And you can see the SMBD clients, you can see when the users are being validated. So basically, a user has tried to connect to the machine, and the machine is verifying that that user has access and also username, password stuff. You can see when it opens a file. So yeah, you can see a bunch of cool stuff. And you can also establish timeframes for Samba sharing. But that isn't the only way files transfer within an org, right? With Samba sharing, what you're seeing is activity that goes over the network. And you're also, if you have the right monitoring in place, going to be able to pick that up via network sensors. There are ways to transfer files that are never going to touch your bro sensors. And this is the first method of, that I'm going to talk about today. And that's Bluetooth file transfer. We can find incoming Bluetooth file transfer activity using this command on Mojave. And I want to highlight this predicate right here. Again, it's a process image path, which basically means instead of process image path, just think binary. I'm looking for activity from the Bluetooth audio D binary and this keyword here. When we first started playing with these Bluetooth logs, we thought this was a count of files incoming. It is not. I don't know exactly what it means. I'm guessing it's a binary, like is it incoming or not? But it is definitely not a file count because in all of our testing, we never got it to go above 1. So here is kind of an eye chart, but I've highlighted the important parts of what you see. You see incoming 1, so this is an incoming file transfer, and then this device string right here, which I wouldn't rely too much on. I think it's, I think the user can change that on their own device, but it might be able to give you some useful clues. And we can find outgoing file transfer activity. Unfortunately, we don't get file names, but we do get this incoming 0, which is why I think the incoming is a binary. And we get these outgoing keywords. So somebody out there in the audience is probably wondering why outgoing activity uses Bluetooth D and incoming uses Bluetooth audio D. I have no idea. It's definitely weird. Maybe it's different on Catalina, but this is what we found on Mojave. You can also find historically connected devices. So if you're wondering how many Bluetooth devices has this particular machine paired with, you can find that in unified logs. And I believe this is first pairing represents, is that the first time that this device has been connected to this machine. I want to do some more testing to confirm that. But you get a MAC address here, which helps you identify that in this case we have 2 different devices because this one, these have different MAC addresses. So that's Bluetooth. And now I'm going to talk about AirDrop. And it's going to get a little confusing because if you know anything about AirDrop, you know AirDrop uses Bluetooth a little bit, but it's not the same as Bluetooth file transfer. It's a distinct system. So yes, AirDrop uses Bluetooth. It's not the same daemon. It's not the same binary. It's not exactly the same subsystem. So just keep that in mind. But in terms of threat modeling, it's very similar because AirDrop activity also does not cross network boundaries. AirDrop activity essentially happens over a local ad hoc network that's built between different machines that are close to each other. So it's never going to touch your bro sensors. The first thing that we thought would be interesting to look for, and I know this isn't unified logs, but it's an important place to start, is you want to look at your AirDrop discoverable settings. And this sharing DP list is what holds them. The important thing to remember is that this is a preference that is stored per user and not per computer. So if you're scanning your fleet and you have machines with multiple user profiles on them, it might be different depending on which user's logged in. So yeah, I would talk more about this plist, but I think for time, I'll move on. The thing that's different between, say, like AirDrop and Samba is that AirDrop is always busy. So just because you see the AirDrop server active does not mean that a device has paired with the machine or that anything has necessarily happened. And the reason for this is the way AirDrop works. So particularly if you have your device set to discoverable, your device is beaconing all the time, saying, hey, I'm here. Do you want to do AirDrop? Because I do AirDrop. And those beacons go out every few seconds. So the server is always going to be active if AirDrop is turned on. So just keep that in mind with this command. But we can find incoming file activity using this AirDrop received upload request phrase. And this is a new predicate I don't think any of the previous queries used. It looks at a subsystem called com.apple.sharing, which becomes important later because this subsystem doesn't only handle AirDrop. It turns out it handles some other file transfer stuff as well. We can find incoming file activity and determine which files were transferred using other sources. So in this case, this really long folder list here is a temporary file that Sharing wrote until it had transferred the file to its final location. So it'll have some long random strings in it. It only exists for a little bit until it gets deleted. This is actually a file system event. And you'll see that this file, I think it's the file system event for it being removed. But you can get the file name. And you can also, if the files are still present, you can use the Spotlight database to find it. So remember how I said that AirDrop and Sharing share some AirDrop and Sharing. Sorry, let me start over. Remember how I said AirDrop is handled by com.apple.sharing and that it is not the only way of transferring files that that subsystem handles? When I ran this command on my machine, what I found was also some files I had transferred from a network drive. So there are some false positives for this, but it's still a good place to start. We can find outgoing file activity, and we can find attempted outbound validated AirDrops items versus actual sent items. And this one is really cool because we can actually see the file name that got transferred, which we don't get for the Bluetooth logs. All right, so I'm sorry I rushed through the last few slides there so I could leave some time for questions. But what I'm really hoping is that we go as a community and build some better detection and solve some mysteries and basically keep all our environments safer by using the information that we can pull from unified logs and whatever other sources we can reach. All right, so that's the end of my prepared material, and then I'll take questions.
Awesome. Thank you very much, Megan. I don't think we have questions from the chat. However, I have a bunch of them because this is very relevant to me. So the first question I have is like, have you been able to deploy any of these things to scraping your real life logs? And what are some of the interesting like false positive stuff that you've run across?
We have done some stuff with Python in order to, because basically you have to. I don't know of any commercial product that mines unified logs right now, which is kind of unfortunate. What are some false positives we found? We found a few users who turned on remote Apple events but don't know how. So that was interesting.
Cool.
Yeah, I think that's about it. False positive wise. What's the other thing I wanted to say? Oh, I forgot to mention this. OS Query has a unified log table, which I haven't played with, so I can't tell you from experience how accurate it is, but I think it's probably a good start, and I'm hoping that that could be an easier source of data, because if you can hook up that, then you can just run scheduled queries and then output to a file and then pick it up with Kafka and then send it on to a SIM.
For sure, for sure. I know that there's also products that will do that for you too, that I will not mention. But that's a really great idea. So basically, your problem at this point is that there isn't really a way to collect these off of devices to use for IDS currently. It's kind of a roll your own kind of deal. Yeah, got it.
And I know, like forensics wise, I think, is it like Black Bag collects them, but not in. As far as I know, it's not like a collect them for analysis and alerting. It's like, we have a machine. We're going to examine this machine. Anyway, sorry.
Got it. Oh, someone definitely just chimed into the chat. Thank you for answering the OS query question I wanted to ask. Perfect. Another question I had was, so I guess this isn't about unified logging, but I'm just really interested in it. How does the Apple Remote Events API work, and what exactly does an attacker use that for? Like, can you just send whatever shell commands you want to it?
It interacts with the GUI, I think.
Okay.
So it's not exactly the Swiss Army knife that I think SSH is. But you could certainly trick the user into clicking on something by supplying the right dialog box.
Got it.
And if you have the ability to move files onto the machine, then you could conceivably, I think, trick the user into clicking on something that would, yeah. So I didn't play around with the scripts as much as I would like. I'm sure that if you talked to like an experienced red teamer, they would be able to give you 1,000 ways you could use remote Apple events to compromise a machine. But
awesome. But it sounds like it's part of like some attack chain. I'm gonna have to look up that because I was not even aware of that API. So thank you very much. Cool. Anybody else in the chat have any questions before we let Megan go? I'm gonna give people a second. I think the other thing that I thought was really interesting is the keyboard whitelisting stuff that you were talking about, essentially. Do you have any recommendations for implementing that? Have you tried that at Target?
So Target is way too large of an environment to list the standard set of keyboards. I will make a note that if you're trying to do this in your environment, the built-in keyboard on your laptop shows up in the unified logs.
Mm-hmm. So
you'll need to figure that out. So I haven't really found a way to do an approved list of keyboards. I threw it in there because I figured it might be useful for people. And also, if you're investigating a particular machine, like not the alerting use case, but if you're just investigating a machine that you know has been compromised, you can list the last few keyboards plugged in, and then you could easily go to the user and say, hey, is this, like, do any of these sound familiar? And then you might be able to figure out if a malicious device had been plugged in.
Sure. Cool. Well, thank you for answering my questions. Sure. And thank you so much for speaking. That was an amazing talk. Round of applause for Megan.
Thank you. Oh, and you can find me on Twitter if you have other questions. Sometimes I talk too fast. Most of the time I talk too fast. Anyway.
I think your pacing was great. Cool. Well, I will let you go. Thank you, everyone, for coming, and we'll see you next time.